as a math shaman, I shall call upon the powers of Aristotle to bring back Euler to life. Cometh Euler, cometh from the dead. Rise. Ah! Oh. Oh. Where am I? Tell me, what year is this?
2015.
Freaking shushuba flubble flops! Show me this postmodern age of mathematics you guys have.
Okay, well, this is T-Mex. It's a high school. What's up, Euler?
Oh, yes. Where do you do such modern mathematics?
In that portable. It's actually Mr. V's portable. Well, his name is Mr. Villarreal. We call him Mr. V. He's very educated in the mathematics department.
Let's meet this V.
Yes.
So Euler, what is this?
This one is actually my identity. E to the I pi plus 1 equals 0.
Where'd you get that from? Where did you get that from?
I'll go ahead and prove it to you. You go ahead and get the basic integration of this baby right here, e to the x. Get this power series. Yes, you apply I to that. So you put I in every single x. Comprehend?
I think you're missing somewhere here.
You keep going.
Okay.
Yeah. So then, once you get apply I, you go ahead and simplify your i's. See right here?
What happened to the eyes here?
Well, if you learned your basic properties of math, you know, your noggin, use it, cancel them i's. So,
Ooh, cross them eyes.
all your even numbers don't have i's. Odds do, yeah?
Okay, okay.
Alright, so you move on to your next step. You go ahead and combine like terms here. You see? I's, no i's. X's too. Alright.
Okay.
Yes, so here you actually want to factor out that I is pretty messy. So,
See what you did
now,
there.
do you see something in common with these two? Come on. No? Maybe?
No.
I thought you wouldn't. Yeah? This right here is the power series of cosine. And this, yeah.
Oh, okay.
And this is the power series of sine.
Is that where you got that from?
Right here. Right here.
Oh, so it's just a simplified version.
Yeah, so you go ahead and you simplify this right here.
Okay.
Now, you make sure you want to move this to the other side.
Where'd you get pi
zero.
from? Did you want to see what happened if pi got there?
No, you're pretty dumb. Pretty dumb. You didn't go to my university in Barcelona, Switzerland. You add the pi, okay? And after you add the pi.
Okay, cosine of pi is
Yeah,
-1,
exactly.
0. Okay. Okay, so you just subtract, add 1?
Yeah, dumb.
Oh.
That's my identity.
I see. It's very interesting, isn't it? Euler.
In this part, we'll be proving the irrationality of E through the proof by contradiction. In proving through contradiction, we have to assume the opposite of what we are trying to prove, which is that E is irrational. So therefore, we're assuming E is rational. In assuming E is rational, we can say that E can equal A over B. With that, we say that A and B are both positive integers, and them being positive integers means that they are greater than 0. So with that, we can assume E is a positive integer, which is greater than 0. We start off with our basic infinite series of e to the x, which is as followed. And with that, we want just e. To do that, we make x equal to 1, which gives us this new series, 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial, and so on. Then we want to multiply both sides of this by b factorial, which is what we do here. And down here is where we actually expand our multiplication, and we're left with b factorial plus so on, so on. We eventually want to get to b factorial over b factorial and so on. So eventually we're going to lead to more, which is right here, where we lead to b factorial over b plus 1 factorial plus b factorial plus b plus 2 factorial, and so on. Once we actually factor this whole expression out, we can cancel out the b factorial at the top, and eventually we're left with just 1 over b plus 1 plus 1 over b plus 1 times b plus 2, and so on infinitely. And this becomes eventually, less than this right here. So this is basically this right here, b plus 1 to the nth power, which just continues on. And this is actually less than the summation of 1 over b plus 1 times 1 over b plus 1 to the nth power. Now when we solve this, we obviously do the a over 1 minus r, which in turn gives us leaves us with 1 over b. And 1 over b, once you substitute b for any number, it will always be less than 1. Now with that final conclusion, we can see where we contradict our proof. Since 1 over b is going to be less than 1, we look back at our first requirements to the proof, which is that e is going to equal a positive integer, making it greater than 0. So if 1 over b is less than 1, then that means that the values of a and b are positive integers and must be between 0 and 1. But that's where we contradict ourselves, because there are no positive integers between 0 and 1. And that proves that e is in fact irrational, because we contradicted our assumption that e is rational.
A little bit about your life as the greatest mathematician ever.
Well, I kind of am a great mathematician, but other than that, I did lose sight at the age of 50, if I remember correctly.
Well, Wikipedia says you lost your eyesight.
Wikipedia? Who's this Mr. Wikipedia?
It's not
No. Okay, look, I looked at the sun once. Once. That's all it took. Apart from that, I did attend the University of Basel at the age of 13. Yes, I studied theology, Greek and Hebrew. From there, 1723, I did get my master's degree in philosophy, and I got a PhD in 1726. Quite some. I published a work in 1726 too on isocraneous curves in a resisting medium. And in 1727, I also published another article on reciprocal arrectangles and submitted an entry for the 1727 Grand Prize of the Paris Academy.
Oh my god, he has a gun!
Ah!